The next session is infrastructure updates. So I'll pass it back to you guys. David, Tom, take it away.
Hey, thank you. Hey, good morning, afternoon, and evening, everybody. So we just got this in two halves, and I will share my screen. Oh, excuse me. That's better. Can folks see the slideshow?
No, we can see your desktop, Tom.
What about now?
Nope.
Still no?
If you're using PowerPoint, go into slideshow setup and select which monitor you want the show to be on.
Yeah. Let me.
If you're doing this kind of sharing, sometimes in slideshow setup, you can say browse deck rather than present, and it'll give you access to a window with the slideshow in it.
So you're saying slideshow. Well, let me try this one. What about now?
There you go. There it is.
Yes.
Yeah. Okay. All right. All right. Had that as a backup. Essentially it's me first. And I'm going to talk a little bit about the work stream, just very, very briefly, that started in Arusha, or at least that Simeon announced in Arusha, and we did some work on, and then give you a little bit of an update on installing and trying Moja Loop in demo mode, which is Mini Loop. I'll give you an update on that. And then David's going to tell you all about how to run Moja Loop in Anger very easily with IAC. So just to touch on the work stream, and it was to assist users to onboard to Moja Loop. As I said, it was announced or initiated as a work stream in Arusha. I created a slide deck, and I've got a link to that below, which is purely and simply a proposal, because that's an AI that I took in Arusha, and I did that, and we've had some initial discussions around that slide deck. And in fact, Paul Macon has actually set up some meetings for next week to progress this. And it's worth noting that we have two parts of this work stream in place today. One with Mini Loop for deploying Moja Loop in demo mode, or at least deploying the hub into Kubernetes clusters in demo mode, and then IAC in production. So let's just cover those two things. Sorry, just before I leave the work stream. This is just from that slide deck, and it was purely and simply a proposal, a starting point. But I do note that we have, as I say, Mini Loop for demo. Can I get this up and running in the least time, least resources? Can it run on a laptop? Can it run on VMs and everywhere, etc.? And of course, on the right-hand side, level 4 is IAC. So just to talk about what I'm working on mainly right at the moment, and the problem statement is that Kubernetes and our infrastructure with cloud native moves very quickly. Kubernetes releases every 3 months, and Miguel alluded to this earlier in his presentation. And current releases can expect about 12 months of patch release. So if 1.24, which is the current release, released at the end of June or the start of July, it gets a support window, and then it gets about another 12 months of patch release. And then the Kubernetes vendors So anybody who creates distributions, micro K8s or Rancher or Minikube, Cube Spray, or all the cloud vendors, they basically keep in line with the Kubernetes release window. Look, I'm trying to be quick, so I'll just point out that we've fallen behind the release schedules for the engines, for Kubernetes itself. And again, going back to what Miguel said in the earlier presentation, some of the Helm charts and some of the other tools and services. And that makes it really hard for people to interact with Moduloop. As I've been saying, you've got to be Miguel or Sam or VJ or you know, a real expert to be able to deploy Moduloop, and that's not scalable. And it's an impediment for our community goal of being able to grow the community. And we're providing really expensive support on Moduloop Help. And we're using, you know, Miguel's cycles to do it, which I don't think is the best use of his time. The two current releases, two current problems, which in the very near term Miniloop 4 release, and just think of Miniloop as the demo installer for Moduloop. You know, we've got some out-of-date APIs. They got EOL'd as of the end of June. It was the last version that you could actually deploy the V1 Beta 1. And we have some out-of-date charts. That's issue number 2, the Pecona chart. And then already, if you look ahead in what's going to be the current release in 3 months' time, version 1.25, we got some other APIs actually becoming EOL'd as well. And the way this works is that you get 12 months or more warning about an API change or something changing within Kubernetes. They deprecate it for 12 months and then they stop serving it. So what's the solution that's available today to help in demo mode with this? There's a Miniloop branch K8s v1.24, which will be Miniloop 4.0 release by the end of, well, by August actually. And what does it do? It essentially Git clones the Miniloop repo. Then you run what do you need to do? You need to Git clone the Miniloop repo into your Linux operating system as a normal user, a non-root user. And then as the root user, you run the K8s installed current.shell. That basically takes care of all the OS prerequisites. It installs micro K8s or K3s distros. It installs the correct Helm, the correct ingress, and it configures the user environment for K8s and for Moduloop deployment. And then you do number 3 there, step number 3, miniloop-local-install.shell, clones the latest Moduloop charts, in this case version 14, release candidate, modifies the charts. Interestingly, it also implements a new non-default and requires a non-default database password. It generates a new one. So there's no more default database passwords, even in demo mode, if you're using Miniloop version 4. And it deploys a database with that password. It deploys Moduloop and it does the health checks, and it sets up so that you can do the testing toolkit. And if I can just show you very briefly before I hand over to David, if I go HTTP Moduloop testing toolkit, you'll see that I deployed earlier I did those 3 steps earlier this evening to Red Hat 8, and then you can do the testing toolkit. I particularly like the mobile simulator here. We can start provisioning. while that's running, you can see that we actually ran the golden path tests with 0 failed assertions on release candidate 14. That's actually done. And we should be able to.
Seeing your screen, the same that you are.
Ah, that's not working, huh? Okay. Forget that. I think I'm out of time. The point being that the testing toolkit comes up on your local laptop, accessing that Red Hat AWS instance, and you can run the mobile simulators, and actually it's a really, really good environment for people to actually be able to see what Moduloop is doing for kicking the tires. And I'll hand over to Dave. I'll stop sharing and hand over to David.
Thanks, Tom. So I'm going to try to pull a Paul Macon trick here. Let's see if it works. That didn't work. All right. Well, can you see the screen right now?
Not yet.
Oh, no, we
Not
can't.
yet?
We see you, David.
That's good. That's a good start. Paul makes it look so easy that I thought I would give it a try, but I might stop. Oh, there it is.
Yes, no, we can see it. But
Excellent. All right, still can see it. All right, so let's go forward here. And we're going to talk about the IEC update from last PI. I just wanted to give a refresher because Simeon gave kind of a challenge for the IAC to have some more definition and what we're trying to solve for. So Tom just talked about the mini loop version, and we mentioned that there's some other use cases such as a sandbox for a hackathon, a POC for a countrywide switch, not production, but essentially to do a POC. And then production grade was, this is something that's going to be, you're going to need to have, more specific requirements addressed by a vendor in that situation. So we kind of put that one off. Then we talked a bit about the history. I'm not going to go over this again because we have a limited amount of time. But we did mention that the effort started on AWS, and so that's where our focus has been. But we're trying to get to the point where we're going to discuss this, where we can make the code base that we have cloud independent, so that we can modularize it to the point where we can bring in different Kubernetes providers, not just different cloud providers, but different managed Kubernetes, et cetera. So I did update this a little bit from last time, and we were just talking about some of the things that we've accomplished. And in terms of the major addition from last PI, it is that we have the first cut of the cloud provider agnostic version that also we've brought in some refactorings to make it more modular and to be able to support modularity across the board. And that is making use of TerraGrunt, and I'll talk a little bit about that in the rest of the presentation. So again, fit for purpose for a countrywide POC or for a sandbox, not talking about supporting production per se in this in what we've created so far in the Moduloop repos. But some of the other things I think is worth pointing out. We do want to start supporting lower resource requirements because obviously as you're starting out, there are cases where you're not going to be able to have such large VMs available from cost perspective. So that is something that we want to try to address in the future. All right, I did present these last PI, and just to show that what we're talking about in terms of making modular so that we can support multiple Kubernetes implementations, either on-prem or with a cloud built kind of using Kubespray as we do in the current solution on top of a infrastructure that's been provisioned on a cloud provider, or having a managed Kubernetes solution. What we want to illustrate here is this red box here. These are the components that really are cloud dependent. And that's what we've focused on to make as modular as possible, so that the next interested party would be able to take what's been done for AWS and then extend it for that cloud provider or on-prem or et cetera. Okay, these are the components that we use that are cloud agnostic, meaning these are third-party components that we make use of. They're open source, and they should be able to run on any cloud. And that's why one of the main reasons that they were chosen. Okay, so the cloud agnostic process, what did we do in this PI in order to support this? And a lot of this work was put together right after the end of the PI. Was talking with Tom in Arusha, and started to lay down some of the reasons why we would want to do either support one cloud provider or manage cloud providers, and started thinking about the easiest way to modularize the code in order to support that. So the structural changes that were made were done. Number one, we changed the way the directories are set up for Terraform so that it would be easy to remove the existing AWS-based ones and swap in different cloud provider versions. Then we used Terragrunt, as I mentioned earlier, to allow this modularization to be extended for different custom modules that we want to support, either in Mojaloop or third-party or vendor-provided modules to swap out. So Terragrunt, if people aren't aware of it, is a project that allows you to just define configuration once, as opposed to copying and pasting it across your whole code base. And it makes it very easy to reuse that across your different modules. And it makes basically the process of having a module, it simplifies that so that you can swap out different modules with ease. So anyway, too much talk about modules, but the bottom line is that the way that it's been set up now, we can swap out modules fairly easily, and it sets the stage for doing that across the board, not just within the cloud-specific pieces of Terraform. So all right, I don't think that this was just a discussion. This is the overall overview design of the different components. I don't think we need to go look at that in detail today for the sake of time. So what I wanted to do is just highlight a couple of the new modules that that were refactored in order to remove all of the AWS specific Terraform code and put them into two specific modules. And the two modules, as opposed to one, is essentially the top one here, the base infra AWS directory. This has the base infrastructure that is used to build the clusters. So for those who aren't familiar, we create the VMs and the rest of the AWS infrastructure. And then we use Kubespray, which is an Ansible library, to actually deploy the Kubernetes cluster. So that's the process that we use in order to stand up the cluster. So in order to make it easy to swap out using, say, a managed Kubernetes, instead of using a homegrown, let's call it, cluster using CubeSpray or another technology on top of custom built infrastructure, we created this so that this could be either eliminated completely if you wanted to use a managed Kubernetes, or if you wanted to go the route of using CubeSpray, you can replace this with a base infra Azure, say. And then you would have the equivalent infrastructure in order to create the security groups, the load balancers, et cetera, and the VMs ultimately, that would be the ingredients to the inventory that would then feed into the Ansible playbook for CubeSpray. And then you could run everything exactly the way that it is run right now, except that this would be changed. And then any references to AWS in terms of IAM and a couple of other, say, S3 configuration that this base K8 uses. And again, the base K8 setup is AWS specific, because imagine external DNS needs to have IAM and Route 53 configuration. Let's Encrypt needs to have Route 53 configuration, et cetera. So there are, let's call them very minor changes that would be needed in this module in order to support the base Kubernetes infrastructure setup for a different provider. So these two modules is where everything that's cloud specific has been isolated, and no other cloud specific references have gone into any of the application specific modules that I'm going to quickly show. So this is the example of the cloud agnostic pieces, meaning there's no cloud vendor specific configuration in any of these. I did cut off one of the modules, but this is almost all of them. So you can see that there's the core module configuration. There is also the state setup. So as the separation of state is going to be a part of version 14, we've already created the separation of the stateful resources from the configuration of the module components that make use of those. So that's already been set up, even though it kind of in advance of that being a requirement for version 14. So anyway, I'm not going to go through any of these. Sorry, Zanzibar. Thank you, Sam. I'm not going to go into more detail about these, but just to point out that all of these have no reference to the cloud provider. TerraGrunt, I'm going to skip over this. For those who are interested, they'll be in the slide deck and you can see later on. But essentially, this is how we're configuring providers, and we're also creating dependencies between modules. And those dependencies allow us to really minimize the bleeding of different configuration elements across the different modules. And that's where you see here, like a dependency for GitLab that's getting pulled into a module that is actually for the, say, Grafana setup or something like that. So anyway, and then in terms of the common variables that we're able to pull out, we're able to make use of the same provider across all those modules. And anybody who's used to using Terraform, you have the pain of having to keep up all your providers that you're using in multiple modules. And if you bump the version in one place, you have to go bump it in 5 different places. So anyway, this allows us to pull all those provider configurations into one place and source it, and then we can remain consistent and only have one place, a single source of truth for those. Okay, so sorry, this should say PI 19. We have the first cloud agnostic code base that's implemented on AWS. And again, I'm not saying that we've done any work to actually extend it to another cloud provider. We're looking for other interested parties to take that code base and move it forward by either extending it on-prem, using a managed cloud, or doing the CubeSpray on top of a different cloud provider. Okay, so I did want to mention quickly that I'm working with a member of the community to test out new versions of the Bootstrap and the platform code. And let's see if I can. Well, I'm not gonna try to change my share. Now, let me try doing this. How much time do I have, Simeon?
You've got 5 minutes left in the session, so.
Okay. Can everybody see that screen? There should be projects, GitLab.
Yep.
Okay. So there were updates that I made to the three main Mojo Loop repos: the IAC AWS backend, the Bootstrap, and the platform. So the versions that were the default branches of these repos were quite out of date. They've all been updated. I've created releases that are now based off of those new default versions of these repos. And we're starting to work on some revamped documentation since the documentation has really gotten out of sync. And let's just call it will be bare bones documentation, but the goal is to have the documentation actually reflect the suggested code base that one should be running now. And as I mentioned, we're working with some other interested parties in the community to get this up and running and get some documentation donated back to the community. So really excited to see that interest, and also excited to get everybody working off the correct and most recent code base. So I'll leave it at there, and thank you.
Thanks, David. Are there any questions? I think I can take one question. Skimming through the chat as well.
I got a question if nobody else has.
All right. I guess no question then. Then I think we will end it up. Thank you. Sorry.
Simeon, I have a question if nobody else does.
Yeah, go ahead. Go ahead, Tom.
So I've been testing Mojo Loop across different operating systems, different Kubernetes releases. You know that I'm working on the ARM. I'm trying to port this thing to ARM as well. So did we ever, or how do we make a decision about what operating systems, Linux distros, Windows releases, hardware, Kubernetes releases, Kubernetes engines, and cloud platforms? Have we got a statement, or should we have a statement about which and what platforms and we actually want to have this thing working on? And how do we decide that?
Actually,
so I can go back to the history a little bit. Not that that should guide you going forward, but I can say that we chose the Alpine Linux for in-container support because it was very small and easy to secure. But as I understand, the Arch Linux is perhaps the more preferred version to be used now. But now there's another overlay on that, which is, you've pointed out to us, which is that ARM architecture support may complicate somewhat the choice of the in-container operating system that we might use. I think Arch Linux is supported for ARM and also for the modern Intel architectures. So that shouldn't be a challenge, but that's something that would have to be looked at. What we did do is not use a really thick Linux like a Red Hat or something like that, because it's just simply too hard to secure in the end, and it's unnecessary. Since what we're running is a microservice architecture, we just basically need basic OS services. We don't need trough and man pages and a bunch of other stuff that you get with those distros. So that was the original choice made. I don't know, that we have a real formal structure for making those choices. It's mostly whoever's sitting in front of the choice thinks about what we're trying to do and makes some selections, shows it to the community, and then we debate if there are alternatives that we might consider. But ultimately, code wins. So if you've got it running and it's working and you can make the claim that this is a supportable thing, then I don't know you're going to get a lot of pushback. I don't know if that helps you with your question.
No, I'll frame it a bit more in chat. I just thought I'd use the 5 minutes to run it up the flagpole and start the conversation. Thanks, Miller.
Thanks, brother. I do want to highlight that the Community Council has a conversation on long-term support, and that's something that I think, Tom, you'd need to be plugged in as well. If Sam is here, I wonder if Sam can speak to that. Sam, would you like to?
Sure. So I would second what you said, Simeon. Nothing much to add in the time we have. I think there are several options that are being discussed there, but yeah, I would say it's being addressed.
Okay, cool. Tom, I'll find a way to plug you into those conversations as well.
Sure. I'll dump the question more fully formed into Slack. I'll be interested in further feedback on it. Thanks.
Okay, excellent. Thanks so much, David and Tom.